So we're beginning day 13 on page 26 of the Do Now. Alexa babysits her cousin. The first week she got paid $9 per hour. So we got paid $9 in week 1. Every week after that, her pay increased by 50 cents per hour. So that's saying that in week 2, we'll be paid $9.50. In week 3, we'll be paid $10. And in week 4, we'll be paid $10.50. The question now is the relationship proportional? And when you see the word proportional, you should immediately think constant unit rate. So now if we look at this table, right, we're doing y over x. So our unit rate for the first is 9, which makes sense because we start out making $9 per hour. Now, if we do $9.50 divided by 2, which you will plug into your calculator, and get $4.75. Now, immediately you should look at these two and say that they're not the same. If they're not the same, then your unit rate is not constant. So this is not a proportional relationship. Because the unit rate is not constant. This was just a refresher on what it means for a relationship to be proportional. Today you're going to be looking at the graph of a proportional relationship. So before we go into that, let's review how we approach the coordinate plane. So we're labeling all of our pieces. So we have quadrant 1 through 4, and it goes in a counterclockwise direction. The origin is our center at 0, 0. The x-axis goes from left to right, and the y-axis goes up and down. Now the next piece that we need to know is how to plot points and identify where points are plotted. So, for example, I want to know where point A is. So I'm going to draw my lines up to point A, and I can say, okay, the x value is 1, and the y value is 9. Your coordinate points should always be x, comma, y. And now I'm going to do the same thing with my next ones. I have point X. So my x value is 5, my y value is 2. Now they're asking me what letter is at the point 2, 4. So 2 is my x value, y is 4. So I'm going to start at 2, and I'm going to go up until I'm at the y value of 4, and I find that it would be point S. And now same thing for 4, 1. Go start at 4, go up to a y value of 1 to find that z lives there. So now, if we look at this table, we will be able to tell that this is a proportional relationship because when I do y over x, I find that I have a constant unit rate of 3, right? So yes, constant unit rate. We never look at the 0, 0 because as we've stated, you cannot divide by 0. Now I'm asked to plot the points. So I start at 0, 0. For 1, 3, I go over to 1, and then I go up 1, 2, 3. For the next one, I go over to 2, and I go up to 6. And now, if I connect my points, you'll notice that they form a straight line. And they also go through the origin because we have that 0, 0 point. So now let's compare this to the next one, right? So if I start determining if this is a proportional relationship, you'll be able to see very quickly that it is not, because my first unit rate is 4, and then my second one is 1.5. So clearly, this is not a proportional relationship. Because no constant unit rate. So now I'm going to plot my points 0, 0, 1, 4. I now go to 4, 6, and then 10, 8. If I connect my points, you'll notice that although we still go through the origin, this is not a straight line. My line changes as I go through. That's because the unit rate changes as I go through my table. So now let's look at the next one. Is this relationship proportional? Well, right away something should catch your eye. This is different because I still can't divide by 0, but this is not 0, 0 like the other ones were. So let's check. 3, 2 gives me 1.5. 4 over 4 gives me 1, so I know it's not going to be proportional. And this is for 2 reasons. There's no constant unit rate. And we have to go through the point 0, 0 for a proportional relationship. Because if you think back to our examples of getting the same amount of money per person, right? If that was what this table was representing, that would mean that I would give an empty table $2. So I would be throwing money away, which doesn't make any sense. So now I'm going to plot the points. So I start at 0, 2, 2, 3, 4, 4, and then 6, 5. So although this is a straight line, which our other proportional relationship was, this one doesn't go through the origin. So now if you look at our examples, right, only one of the 3 was a proportional relationship, and that was the first one. The first one was a proportional relationship, and the graph was both a straight line and went through the origin. If either of those 2 things are not true, like we see with the second one or the third one, it will not be a proportional relationship. So characteristics of a graph, it must be a straight line, and it must go through the origin. So whenever you look at a graph and it's asking you, is this proportional? You have to check for those 2 things. Now let's look at an example. Richie sells sandwiches at a deli for $2 each. Create a table for this situation, right? So this is going to be a proportional relationship. So I know that if I don't sell any sandwiches, there's no cost. There's no money. If I sell 1 sandwich, I get $2. If I sell 2 sandwiches, I get $4. If I sell 3 sandwiches, I get $6. So, is this a proportional relationship? So if I plot my points, I have a straight line that goes through the origin. So yes, this is a proportional relationship. The origin is 0, 0. And like we said, that means that you earn or you pay, depending if you're Richie, $0 if you sell 0 sandwiches. Now they're saying, what should we label the x-axis? So what do these values represent? So if we look, we're looking at, for example, this point, 1, 2, right? That says that for one sandwich, you pay $2. So this is representing the number of sandwiches, and this is talking about the money. Now you have 3 examples here. Only one of these is proportional. Do your best and circle which one it is.